Well, now we're at our next part of our little mathematical journey, looking at logarithms today. So for anyone doing extension 1, a logarithm is the inverse of an exponential function. For anyone doing 2-unit and a bit confused, logarithms and exponentials, they kind of go hand in hand. Log undoes exponential, exponential undoes log. So like adding and subtracting undo each other, multiplying and dividing undo each other, taking logarithms and exponentials, they undo each other as well. So, getting into it then, if we have something like a to the x equals b, this here is an exponential equation, or y equals a to the x is also quite nice. In terms of what we've got, a is the base here. Okay, so a, we call this our base. And our x here is called our power, or our exponent. Or our logarithm. Okay, so where and how is this useful? What is kind of the point? So, if you have an equation like 3 to the power of x equals 10, right now we can't really solve that. There's not a whole bunch we can do. So we could probably guess x is, 2 point something, because if x was 2, that would be 3 squared. 3 squared is 9. Or if x was 3, it would be 3 to the power of 3, which is 27. So x is 2 point something, probably pretty small. But right now, there's not really a way of solving this unless you kind of recall back to year 10 logarithms. So, getting onto logs, getting onto a little bit of rearranging, we are going to rearrange everything here into a log form. So if I have y equals a to the power of x here, I can write that in log form. It's going to be log base a, same base. Okay, so log base a is how we actually talk about it. So log base a, so we're talking about base here, base is a. Log base a of y equals x. Okay, we're trying to get that x by itself. We're trying to figure out what x is. So x by itself, okay, so x by itself here, that's all good. That power, that exponent is by itself. And these two things here are equivalent. So you can say, you can convert between these two whenever you like. Y equals a to the x, log base a of y equals x, and you will need to know that. It's convenient to know that. It's helpful to know that. You will use it a lot throughout this unit. Okay. So far what we've done a lot of work on exponentials. We've integrated, we've differentiated. We're going to do the same with logs. But with logs, there's a bit of work we need to do first because there's a whole stack of laws that apply to logs. Okay, I'm going to run through those laws with you now. I'm not going to prove them. I'll prove them in a different video because proving them take a while. But basically, if exponentials and logs are similar, we had a whole bunch of laws that apply to exponentials known as the index laws. And because of our index laws, we get a whole bunch of log laws as well. Log laws you'll need to know, you'll need to be able to apply them, and they'll cause you a little bit of fun until you really get a hold of them. Let's have a look at them. So log laws, one at a time, in order of, well, just in order of how they come to mind. Firstly, log base a of x plus log base a of y equals log base a of xy. Okay, so if you've got a plus in there, it comes a multiply inside a log sign. That's the first log law. Second log law, log base a of x minus log base a of y equals, and you can probably guess it, log base a x over y. Okay. Third log law, this one's very important in terms of solving logs, rearranging logs, working with logs. Log law 3, stellar, quite important. It says log base a of x to the n equals n log a of x. So if we have the log of x to the power of n, that power can come out the front. And that's going to be very convenient for us later on. Okay. Going down, log law number 4. So there are 3 main ones for now. Next ones are really just kind of definitions. So if you have log law 4, if you have log base a of a, that's equal to 1. Okay. And you can prove this by putting it back into exponential form. The equivalent exponential form here is just saying that this a here, base, log base a of 1 equals a. Okay, so yeah, that is equal 1. Work the forms. In terms of your a's, which a is which? This a is that a, and this other a is coming from inside there. That's the 4th log law. The 5th log law, log base a of 1 equals 0. So that's saying that a to the power of 0 equals 1 is the equivalent base form. Okay, we know that. We've seen that many times before. There are our basic log laws in a nutshell. You need to memorize those. They, as far as I'm aware, are not on the formula sheet. So, yeah, I will write them down now. I'm going to put some examples up of this because the log questions do get quite comprehensive. In terms of doing questions, there's normally multiple ways of doing something, of doing questions. And I mean, if there's a way I do it and you do a different way, or your teacher does it a different way, or whoever does it a different way, that's fine. Let's just make sure we get the same answer in the end. Okay, there's a lot of ways we can go about things, a lot of different varieties. And like I said, I'll try and get another video up soon on proofs as well. Thanks for watching, and yeah, good luck with your logs.